In this segment, we're going to take an example for naive Gaussian elimination. Naive Gaussian elimination is a technique to solve simultaneous linear equations, and we'll look at an example to do so. In this segment also, we'll only talk about the forward elimination part of it, and in the next segment, we'll talk about the second part of Gaussian elimination, which is called back substitution. So we'll look at the following given sets of equations. So let's say somebody gives you a set of equations which looks like this: 25, 5, 1, 64, 8, 1, 144, 12, 1, and says that A1, ace of 1, ace of 2, ace of 3 are the three unknowns, and the right hand side vector of these three equations, three unknowns, is given as follows. Now we're going to show the forward elimination steps, which we need to understand that in the forward elimination steps what we are doing is that we are converting the coefficient matrix into an upper triangular matrix, and see what the changes will take place also in the right hand side vector based on that conversion we are trying to do. So what that means is that we got to make this element to be 0, this element to be 0, and this element to be 0, so as to be able to make this coefficient matrix to be an upper triangular matrix. So how we're going to go about doing that is by understanding that forward elimination has n minus 1 steps itself. So forward elimination has n minus 1 steps. So since we have three equations, we'll have 3 minus 1 equal to 2 steps. So what's going to happen in the first step, these two numbers are going to be converted to 0 or made to be 0 by doing some matrix operations. And in the second step, we'll be now looking at the what's below the second row, second column, and make this to be 0. So in the first step, you're making everything below the first row in the first column to be 0. In the second step, you're going to make everything below the second row in the second column to be 0, so as to convert it into an upper triangular matrix. So let's go and see what we'll have to do in the first step. So if we have the first step of forward elimination, how we're going to go about doing this? So what that means is that we've got to make this to be 0, make this to be 0. So the way to do it is to we'll divide this first equation by 25 and multiply it by 64 and then subtract it from there, because that will make it to be 0. Same thing here, we'll divide this by 25, multiply by 144 and subtract it here, and that will make it to be 0. So we are looking for multipliers of this equation so as to make this to be 0 and this to be 0. And let's go and see what that means. So since we have, we're going to divide, so let's suppose we're looking at row number 2, we're going to divide by 25, multiply by 64. So that gives me a multiplier of 2.56. So what that means is the first row which I have, which is 25, 5, 1, 106.8, that's the first row which I have. I'm going to multiply this by 2.56. And the reason why I'm going to multiply 2.56 is because this is going to become 64 then. So I'll get 64, 12.8, 2.56, and 273.408. So by making this to be 64, now I can subtract this particular multiple of the first equation from the second equation. So the second equation is like this: 64, 8, 1, 177.2. So I'm writing in an augmented fashion this particular row. 64, 8, and 1 are the parts of the coefficient matrix. 177.2 is the right hand side vector. So I'm going to take this particular multiple of the first row and put it there, and I'm going to subtract it. So you do need to follow the algorithm exactly as shown in the example, otherwise you're not following the naive Gaussian elimination forward elimination steps. So I get 0, I get minus 4.8, minus 1.56, and then I get minus 96.208. So this becomes your second equation now. 0 times ace of 1 minus 4.8 ace of 2 minus 1.56 ace of 3 is minus 96.208. So that takes care of the second row. Now I got to take care of the third row. In the third row, what I said was I'll have to divide by 25 and multiply by 144, and that's what's going to make the third row first column to be 0. So this number here turns out to be 5.76. So I'm going to take the first row which I have, which is 25, 5, 1, 106.8, and I'm going to multiply it by 5.76. And what I'm going to get is 144, 28.8, 5.76, and 615.168. And since this has become 144, now I can subtract this part from equation 3. So I'm going to write my equation 3 here, which is 144. The elements are 144, 12, 1 of the coefficient matrix, and 279.2 is the right-hand side element of the third equation. And now I'm going to take this and write it down underneath it so that I can subtract it. So I subtract it, and what I get 0, minus 16.8, minus 4.76, and I get minus 335.968. So that's what I get as the third equation. So if I rewrite my equations now, this is considered to be the end of the first step of formulation. And as I said that if you have n equations, you have to conduct n minus 1 steps of forward elimination. So this is the end of the first step of formulation. I'm going to get the equations look like this in the matrix form. So first equation does not change because that's what we use to make the first column under the first row to be 0. Then this became 0, minus 4.8, minus 1.56, and minus 96.208. This number here stays to be 106.8. And this one here is this equation which we just found out, 0, minus 16.8, minus 4.76, and minus 335.968. So that's what we get at the end of the first step of formulation. So let's go and see that what do we get at the end of now. Now what do we get at the end of the second step of formulation? So if we're going to look at the second step of forward elimination, let me go back here to this matrix form here. Now what we want to do to this particular set of equations here is that we want to make this to be 0. So we want to use the second row, second column, to make everything below the second column, second row to be 0. So we're going to use the second row, second column to make everything below the second row in the second column to be 0. So since there's only one element, that's the only one which we need to make to 0. So what that means is that I have to divide this second equation by minus 4.8 and then multiply by minus 16.8 to get the multiplier so that I can do the subtraction and get this to be 0. So if I take 0 minus 4.8 minus 1.56, no, let me write down the multiplier first. The multiplier will be minus 16.8 divided by minus 4.8, because you got divide by minus 4.8 multiplied by minus 16.8, and that turns out to be 3.5. So I'm going to write down the second equation, which is like this, and this whole thing needs to be multiplied by 3.5, because that's the multiplier which we obtain, and we get 0, minus 16.8, minus 5.46, and minus 336.728. Now this needs to be subtracted from the third equation, which is minus 0, 16.8, minus 4.76, and minus 335.968. And I'm going to take this multiple of the second equation now, which is 0, minus 16.8, minus 4.46, minus 336.728. And I'm going to subtract it. I get this, and I get 0 here, 0 here, 0.7 here, and 0.76 here. So that becomes my now third equation. So at the end of the second step of forward elimination, which is also the end of the forward elimination steps, because I have 3 equations, 3 unknowns, so I only need to conduct 3 steps of forward elimination. I get 25 here, 5 here, 1, 106.8. Then the second equation stays the same, and this becomes minus 96.28, and the last equation is 0, 0, 0.7, and 0.76. And that's the end of the forward elimination steps. And in the next segment, I'm going to show you to do back substitution to be able to get our solution to a set of equations. And that's the end of this segment.